see how you're going to run a regression and do a scatter plot in Excel. So there's a couple ways to do a scatter plot. You could do that first, and all you're going to do is highlight the data, go to Insert, and then Scatter, and then choose a scatter plot, and it does it for you. So they have attendance on the bottom and bet amount on the y-axis. So that's one way to do a scatter plot, but if you just run a regression, it'll come up with one for you. And so to do that, you highlight it again. Well, you don't have to highlight it, but you go to Data, and then this doesn't have the analysis tool pack added in yet. So just a second. So you might have to do this on your Excel, but you go to Add-ins, and then analysis. Looks like it already had it. It's a different version of Excel than I have. Okay, this is what you want. So after you do the add-in, you can just go to Data Analysis in the corner, and you'll scroll down to Regression, and then you put in your Y variable, your X variable, and so we're seeing the impact of attendance on the betting amount, and so attendance is going to be our independent variable, and we're seeing its effect on the dependent variable, which is the bet amount. So we would highlight attendance, and if you highlight the label, you need to select label right there, so that it doesn't count that as a data point. And it's kind of nice to do that because then all your output will be labeled for you. And so then you select your X variable, and then we're going to want a line fit plot, so that'll bring out our scatter plot for us, and it'll make it for us. And that.
Where is, oh, never mind, thank you.
Okay, so that should be all you have to select. And then you hit OK, and it comes out with your output in a new worksheet. So to make it a little bit easier to read, like that. And then the table, how they have the tables is a little hard to read sometimes. So the red dots, that's the predicted regression line. And to me, it's easier if you just delete that, and then you can look at the data set, and then if you right-click on that, you can just add a trend line, and it's a lot easier to see. And then you can select to have the R-squared in the equation on the graph, but you don't need to do that. So that'll add your line in. And so the blue dots are actual data points showing the correlation between bet amount and attendance.
Can you just say that again?
Yes.
Of how you got the linear, that line instead of the other one that was there?
So you had the red line, and so you the red dots,
Mm-hmm.
and that is the same thing as the trend line that I just put in.
Okay.
And so you can just select that right-click and delete those data points, because I think it's harder to read with those giant dots. And so then what you'd want to do is select the blue dots, right-click, and then go to Add Trend Line.
Thank you.
Okay, and so basically what this scatter plot is showing us is it's showing us the correlation between bet amount and attendance. And so we see that the line is pretty steep, there's a pretty big slope, and so you can tell that the amount of people there has a huge impact on the total amount of bets, which makes sense because if you had a really low number of people, you're going to have a really low number of bets unless for some reason you get a lot of really big spenders or whatever. And so it should make intuitive sense most of the time when you make these scatter plots. And you can see our R squared is really big, which is the amount of variance that, it's the amount of variance in y explained by x. And so if you remember, he had a graph the other day where he said you have some average amount of achievement, we'll say. And so the amount between the average and the line. So let's say we're talking about this data point right here. So this amount is explained by the model, and this amount is unexplained by the model. And so this is the variation not explained by our x variable, and this is the amount of variation explained by our x variable. And so our R squared is this distance divided by this total distance. And so if we have a number close to 1, that means most of the variance is explained by that amount. And so, oh wait, I actually have this backwards. We want attendance explaining that amount, so I put...
Isn't that actually right? Because it's that amount, if you look at it in millions of dollars, wouldn't that depend on how many people are there, not the other way around?
Yeah, and so our dependent variable goes on the x-axis. Our dependent variable goes on the y-axis. And so our bet amount depends on attendance.
Oh, so it's back, okay.
Yeah, so I put those in wrong. So I'll redo that. So we want y to be the bet amount. So I'll redo that real quick. So, again, our R squared is really high because that's, again, just the square of the correlation between the two variables. So either way you have it set up, you'll have the same R squared. But this way it makes sense because the number of bets doesn't influence the amount of attendance. That just doesn't make sense, but it does make sense the other way. So that's kind of what you can gather from this scatter plot. And another thing you want to look for in scatter plots is how close the data are to the trend line to see if it's a good fit or not, which I think it asks about at some point. But so if you had data that, and you had, your data was like really spread out like this, it's not, this trend line isn't a very good fit. I mean, it's generally saying the plot of the data, but if this line wasn't already here, like it'd be hard to say which direction the line should really go in. And so you can see by looking at the data that it's not a very good fit. Like that might be just as good of a fit when you have the data all spread out like that. And so in this scatter plot, all the dots are really close to the line, and so it's a pretty good fit. And you'd also be worried if you had data going like in a pattern like this around the line, and that's something called heteroscedasticity, which you talked about a little bit on Tuesday. But basically you want the data uniformly spread around the line to be a good fit. Because this isn't really a linear trend. And obviously, like, this kind of equation can only measure a linear trend because it's basically the y equals mx plus b form if you took algebra at some point. And so it's just, basically you're just using the equation of a line. And so if your data isn't following the linear pattern, then regression isn't going to help you at all. So hopefully that kind of makes sense. Okay, so that's kind of